Elementary Statistics. Joshua P. Tamundong, GK College, BFA. This is my presentation. Inference for two population parameters, week 8. Inference for the two population parameters. Inference about the parameters of a distribution are made using a random sample of data drawn from the population of interest. Estimation is the process of making inference from a sample about an unknown population parameters. An estimator is a statistics that is used to infer the value of unknown parameter. Inference for two population means independent and dependent samples. What is the inference of two population means with independent samples? Inference about two means with independent samples, assuming unequal variance using independent samples means that there is no relationship between the groups. The values in one sample have no association with the values in the other sample. Two population means goal. Inference for two population means goal. Hypothesis test or confidence interval from the average difference between two populations. There are two designs possible. 1. Independent samples design. The data values gathered from one sample are unrelated to the data values gathered from the second sample. 2. Dependent samples design. Match paired subject are paired matched, so they are as much alike as possible in terms of characteristics other than the variable of interest before measurements on the variable are made. Example of independent samples. Independent samples design. The sample size can be different. Independently select a different sample from each of the two populations. Example, randomly select 35 males and 35 females. Measure their diastolic blood pressure to see if there is a significant difference based on gender. The two populations of interest are 1. Blood pressure for male and 2. Blood pressure for females. Notice the two samples were selected from the populations without trying to match people based on family or personal history in terms of health. What is an example of two means independent samples? For example, to compare heights of males and females, we could take a random sample of 100 females and another random samples of 100 males. The result would be two samples which are independent for each other. Examples of dependent samples. Dependent samples design match paired subjects are measured twice, apply both treatments to the same subjects. Sample. Examine pre-test and post-test scores from the same person. To this for a total of 50 students, this can be used to examine how much a student learned in the class. Now, students who already knew the materials will not show much improvements or increase in knowledge, while students with detailed knowledge of the subject should show vast increases. This eliminates comparisons between students who have period knowledge and those who do not for a given subjects. More than two dependent or independent samples. Of course, in the case of independent and dependent sampling, there can be more than two samples. The important thing is that in the case of independent sampling, the individual groups or samples have nothing to do with each other, and in the case of dependent sampling, a respondent appears in all groups. What is comparing the means of two independent samples? The independent samples t-test compares the means of two independent groups in order to determine whether there is statistical evidence that the associated population means are significantly different. The independent samples t-test is a parametric test. This test is also known as independence t-test. What is the difference between dependent and independent means? The independent variables is the cause, its value is independent of other variables in your study. The dependent variables is the effects, its value depends on change in the independent variables. Inference onto population proportions. Inference for two proportion. Let's summarize. In inference for two proportions, we learn two inference producer to draw conclusions about a difference between two population proportions or about a treatment effects. 1. A confidence interval when our goal is to estimate the difference, and 2. An hypothesis test when our goal is to test a claim about the difference. Both types of inference are based on the simply distribution. The distribution of the difference in sample proportions. In the selection, distribution of difference in the sample proportions, we learn about the simply distribution of difference between sample proportions. We use stimulation to observe the behavior of sample difference when we select random samples from the two populations. Every simulations begin with assumptions about the difference between the two population proportion from the stimulated. Simply distribution we could determine if a sample difference observed in the data was likely or unlikely. A data result that is unlikely to occur in the simply distribution, providing evidence that our original assumption about the difference in the population proportion is probably incorrect. This logic is similar to the logic of hypothesis testing. Null and alternate hypothesis. In order to perform a hypothesis test in the previous situations, we need to examine the issue at hand, which is whether the population's proportion P1 and P2 are equal. The null hypothesis say that they are equal. H0 P1 equal P2. There are three possibilities for the alternate hypothesis. Mean and standard deviation. The test statistics is based on the difference between the sample proportion P1 minus P. When the sample size is large, this difference is approximately normally distributed. The mean and standard deviation of this distribution are mean equals P1 minus P, standard deviation equals P1 1 minus P1, and P2 1 minus P2 and 2. The mean of sample difference between sample proportion is equal to the difference between the population proportion P1 minus P2. The standard error of difference between the sample proportion is related to the population proportion and the sample size. Estimating the difference between two population proportions. In the section, estimate the difference between population proportion, we learn how to calculate a confidence interval to estimate the difference between two population proportion or to estimate a treatment effective. Every confidence interval has the form statistics plus minus margin of error, statistics plus minus margin of error. To estimate a difference in population proportions or a treatment effective, the statistics is the difference in the sample proportions. So the confidence interval is difference in sample proportion plus minus margin of error. Hypothesis test for a difference in the two population proportion. In the section Hypothesis test for a difference in population proportion, we tested claims regarding the difference between the two population proportion or a treatment effective. In testing such claims, the null hypothesis is: the alternative hypothesis is one of three. These are equivalent to following comparison of P1 and P2. We use the same criteria for determining if a normal model is a good fit for the sampling distribution. Each sample match have a less 10 successes and failures.